Let's take a look at this unit. We got section 3.1, Quadratic Functions and Applications. And it talks about vertex form. So let's take a look at that. Now, vertex form is when you have it of the form f of x is equal to a times x minus h squared plus k. Now, the sign that's before the h and k can be anything. It could be positives, negatives. You just have numbers there. And a is a number also. Now, if a is greater than 0, if it's positive, that means your graph's going to open up. If a is less than 0, it's negative, that means your graph's going to open down. And if you have it in vertex form, sometimes that's called standard form in books, but this book calls it vertex form, then your vertex is given directly by hk. Now we have something called the axis symmetry. And the axis symmetry is x is equal to h. And then you either have a min or max. You won't have both. If your graph opens up, you'll have a min. If your graph opens down, you'll have a max. And this will be equal to k. So let's take a look at an example, and we'll find all the different pieces. We got f of x is equal to 3 times x minus 2 squared plus 4. Now, the important part is that you got x plus a number or x minus a number squared. The other two numbers are optional, because if you don't have the a here, it's by default 1. And if you don't have the k over here, it's by default 0. Let's identify all of our different letters. The number that's in front of our parentheses right here will be a, so a is 3. Now this will be our h, and it'll be opposite sign. So h is going to equal to a positive 2, because that's negative 2. And our k is the number here at the end, and it stays whatever sign it was. Well, it was positive 4 to begin with, so k is going to be a positive 4. Now, if you're wondering, well, why do I flip the sign on this the h? It's because our formula has a minus in it. Anytime you have a minus, that flips signs. Okay, to begin with, a is equal to 0. It's positive, so I know my graph's going to open up. Now our vertex. Our vertex is hk, which was 2, 4. Now I'm just going off the formulas over here. Our axis symmetry is x equals h. And so h was 2, so axis symmetry is x equals 2. Now our graph opens up. Since our graph opens up, that means we're going to have a min. And your min is equal to k, which was 4. Now to graph this, I go to my vertex, 2, 4. And my vertex would be right here. Now our axis symmetry is x equals 2. So axis symmetry is an invisible line at x equals 2. And min is 4. That doesn't really help us much on the graphing. That's more of if you have questions, I ask you about that. And our graph's going to open up, so we know generally what that looks like. To find out what this graph looks like exactly, we'd have to pick a point. Like if I plugged in x equals 0, for example. Now you don't want to pick this is x equals 2. You do not want to pick one right next to it. You'd like to go 2 over. Sometimes when you pick one right next to it, it doesn't really give you an idea of what the graph looks like. So we're going to plug that back in our original function. So we got f of x, which is y, equals 3 times 0 minus 2 squared plus 4. 0 minus 2 is negative 2. Negative 2 squared is 4 times 3 is 12. Plus 4 gives us 16. Okay, so that's 4. This is approximately 8. That'd be 12, and this would be approximately 16 up here. So there would be my point, and then my graph passes through that. It has a U-shaped graph to it, as close as I can draw it. Now the axis symmetry. Once you have this side, you can flip it over, and that'll automatically give you the right side. So it looks like that. Now to graph this on the calculator, just pretty much enter as you see it. So if I press my y equals, press my clear to clear out wherever's not a line, I do 3 beginning parentheses, x minus 2, closing parentheses, and then x squared plus 4, and then graph. And you see that we see just the bottom piece right here, but that's our graph. Now that's vertex form. Now, the next topic here says to write it in vertex. Well, write f of x equals ax squared plus bx plus c in vertex form. Which implies that if we have an f of x is equal to x squared minus 4x plus 1, for example, and we want to write this in vertex form. Some books call this general form, where it's ax squared plus bx plus c. So for our vertex, or for our quadratic, I should say, transforming, or changing, right, changing from standard form to vertex form. Step 1, divide everything by the number in front of the x squared. Step 2, take, now actually divide, what am I thinking? Completing the square. Factor out, let me think about this for a minute. Factor out, step 1, group the terms with x's together and the number by itself. Okay, so what that means is we're going to have x squared minus 4x plus 1. So we're grouping the x's together and grouping the number by itself. You might look at that and say, well, you haven't changed anything. Well, no, we haven't yet. Step 2, we're going to factor out the number in front of the x squared from only the first group. Well, the number in front of our x squared is a 1, so I factor out a 1, and that gives us x squared minus 4x. Doesn't change anything, does it? Okay. Step 3, take the number before the x, multiply it by 1/2, square it, and both add and subtract that number inside of the first parentheses. I don't usually show this in class, so this doesn't flow as smooth as it has in other processes. Okay, take the number for the x. Number for the x is a negative 4. You usually do this on the side. So you got negative 4 times 1/2. You want to square it. Negative 4 times half is negative 2, and negative 2 squared gives us a positive 4. It's always times a half, it's always squared. And then both add and subtract that number inside the first parentheses. So we're going to have x squared minus 4x plus 4 minus 4 plus 1. Step 4, group the first three terms together and the last term by itself inside the parentheses. Well, what I mean by that is we group these three terms together and group this one by itself. Step 5. Factor the first group from step 4 well, this x squared minus 4x plus 4 factors as x minus 2 squared. So again, we factored the first group. Now, if you're wondering, well, how does he do that so fast? There's a trick to it. Whatever number's right here, right before he squared, is always what goes right here, sign included. Step 6. Multiply the number that we factored out in step 2. In step 2 by both groups. So this 1 here, we're going to multiply by our first group and by our second group. So we're going to have 1 times x minus 2 squared, and we'll have 1 times negative 4 plus 1, which gives us 1 times x minus 2 squared. 1 times negative 4 is negative 4 plus 1, which gives us 1 times x minus 2 squared minus 3. And this is in standard form. That would be our answer. We can get rid of the 1. That's basically our answer. If I were to go further and it was asking me for the vertex and all that, remember we can identify these letters. A is whatever number's here, which is the 1. This is going to be our h, and it's always opposite sign, so h would be 2. And this is our k, and it stays whatever sign it was, which was negative 3. And then you could go further. But that's how you rewrite a quadratic into vertex form. Now, find a vertex of a parabola by using the vertex formula. So let's talk about that. Let me clear this off. That's kind of tedious to rewrite that in vertex forms. Not that straightforward. We got an easier way. If it is in general form, which is f of x is equal to ax squared plus bx plus c, then if a is greater than 0, it still opens up. If a is less than 0, it opens down. Our vertex is going to be negative b over 2a, f of negative b over 2a. Our axis symmetry will be x is equal to negative b over 2a. And our min or max, min again is when your graph opens up, max is when your graph opens down. Your min or max is going to equal 2k. Okay, let's try that again. F of negative b over 2a. Now I'm going to do an example here. Now I'm not going to do the graph. The graph you just plug in your calculator and it gives you the answer. Let's say I got f of x is equal to x squared minus 6x plus 7. First off, if I identify my a, b, and c, a is whatever number's in front of your x squared. So a is 1. B is whatever number's in front of your x, which is negative 6. And c is your number at the end, which is 7. Now, since a is positive, I know my graph opens up if I was going to graph it by hand. Now, this formula here is called the vertex formula. And some people have trouble interpreting what in the world that's saying, so we're going to break that down. Our vertex formula. Step 1. Identify a and b. Well, we already did that above. We said a is 1. We said b is negative 6. Step 2. Plug a and b into negative b over 2a and simplify. So negative b was negative 6 over 2 times a, and a was 1. Negative negative gives us positive, so we got 6 over 2, which gives us 3. Now this right here is the x part of the vertex. So that's the x part of the vertex. Step 3. Plug the value from step 2 into the original function. So we're going to have f of 3 is equal to 3 squared minus 6 times 3 plus 7. 3 squared is 9, minus 6 times 3 is 18, plus 7, which gives us negative 2. And this is the y part of the vertex. So after I get done doing that formula, our vertex is going to be equal to 3, negative 2. Now our axis symmetry. Axis symmetry will be x equals 3. If you're wondering why, if you look at your formula, notice that this negative b over 2a matches the x part of our vertex. So after you have your vertex, you pretty well have the other items on this. Now we said our graph was opening up, so we're going to have a min, and it's going to equal to negative 2. And again, if you're wondering why, if you look at this, we said the min is equal to this, f of negative b over 2a, which happens to match the y part of our vertex. So again, the vertex is the main thing behind these. Now I'm not going to graph this. Maybe I'll sketch it. 3, negative 2 is right here. And then if I have another point, I can see how much it actually opens up. But it's definitely going to look something similar to this. It's just maybe closer in or closer out or further out. Okay. Now that was find the vertex of a parabola by using the vertex formula. Applications I won't show in this presentation. Creating quadratic models using regression. So let me clear this off. Now if you're given points, given x and y, let's say I got negative 1, negative 2, negative 1, 0, 1, and 2. And this is 12, 8, 1, 3, and 21. So I've gathered some data points, and I want to come up with a quadratic model that best represents this. I need to first go put these in my calculator. before we do that, let's make sure our modes are all set correctly. Or not modes. Yeah, diagnostic mode. Okay, so we're going to go under our catalog. So we'll do second and then 0. And then you push this button that looks like X and -1. And that'll take it down to the D's. Specifically, we're looking for diagnostics on. You could also, if you don't get that, just keep doing down arrow, and you eventually get to the D's. And eventually get to diagnostic on. And then we press enter twice. Now you only have to do that one time. You don't have to do it anymore unless your batteries go dead. So now we're going to go to Stat, and we're going to go into Edit. You may or may not have numbers here. If you have numbers here, you just press your delete, and it'll delete those numbers. Now we're going to put our X values in L1 and our Y values in L2. So -2, -1, 0, 1, and 2. And then I'll go to my L2, and I got 12, 8, 1, 3, and 21. Now if you mistype a number, you can use your arrow keys to go up and retype. Once you got it highlighted, just retype your number. Once you're all done, you do a second mode to exit out. Now I'm going to press clear to clear off the screen there. Now I'll push my Stat button, right arrow to Calc, and we want to choose Quadratic Regression. So I down arrow to it and press enter on it, or you can simply press the number that's in front of it once you get to the screen. Then I press enter and press enter again. So our model is y is equal to ax squared plus bx plus c. And we're going to plug in the values of a, b, and c. And I'll round them to 3 decimal places. So that's 3.786. So 3.876 x squared. Now b is 1.3. So I have plus 1.3x. And then c is 1.429. And that'd be our quadratic model. Now the r squared is how good is it? And the closer it is to 1, the better the model is. This is 0.8565, and it's a little bit off, but you know, it's not totally off. If it was 0, if r squared is equal to 0, that means that there is no quadratic pattern to it. Okay, that was section 3.1. Let's take a look at section 3.2. Let me grab a drink here. Okay, I'm going to look at the first 2 topics. I'm not going to cover every topic in here just because I don't have time. Now we have some definitions. We have a variable, which is a single letter. We have a term, which is a number times a variable, and I put an S on there to indicate you can have more than one, or a variable times a variable. And again, I'll put an S on there to indicate you can have more than one. We have the coefficient, which is the number in front of the term. We have a monomial, which is one term. We have a binomial, which is 2 terms. And we have a trinomial, which is 3 terms. And then we have a polynomial, which is what this section's about, which is 1 or more terms. We have a degree, which is your largest power of x. We have standard form, and this is where your terms are arranged from largest power down to smallest power. We have our leading term, which is the first term when the polynomial is in standard form. And then we have something called leading coefficient, which is coefficient of the leading term. Now, leading coefficient. I'm going to just refer to that as coefficient. And we have our degree. Remember, your degree is your largest power of x. We have something called the leading coefficient test. And we have some possibilities here where we have a positive coefficient. We have a negative coefficient. We have an even degree, and we have an odd degree. Now, if you got an even degree and positive coefficient, then it's up to the left, up to the right. If you have a even degree negative coefficient, it's down to the left, down to the right. If you have an odd degree, then it's down to the left, up to the right. If you have an odd degree and negative coefficient, it's up to the left, down to the right. Now, what the leading coefficient test tells you is what is the graph doing as it goes clear to the left, what's it doing as it goes clear to the right. It tells you nothing about what it's doing in the middle, just what it's doing in the far end, the end behavior. So if I had a problem, if I had, for example, f of x is equal to negative 2x to the fourth minus 7x plus 3. And the question is, what's it doing the end behaviors? We always base it upon our first term when it's in standard form. And I notice this one has a negative coefficient. And your degree is your largest power of x, which will also be the power of your first term here. And this is an even degree. So I'm going to go look that up in my table. Even degree. Now, here's an even degree. And so we got two possibilities, either positive coefficient or negative coefficient. This one was a negative coefficient, so this is down to the left, down to the right. So down to the left, and down to the right. Now, I don't know much about this graph, but all I do know is as it's going clear to the left, it's going down. As it goes clear to the right, it's going down. It could be doing anything here in the middle. That's all I know from that test. But this is our answer. Identify zeros and multiplicities of zeros. If I have this right here, f of x is equal to x minus 2 to the third and x plus 1 to the fifth. Now, first off, define zeros. Because it says, what does it say? Identify zeros. Define zeros, you always do the same thing. You set your function equal to 0. So we've got x minus 2 to the third times x plus 1 to the fifth equal to 0. Step 2 would be to factor this, but this is already factored. Step 3 is set each factor equal to 0. So we'll set x minus 2 equal to 0 and x plus 1 equal to 0. And that would give us x equals 2 and x is equal to negative 1. And those would be our zeros. Now, multiplicity refers to how many of them do you have. And it's always based upon the power you have up here. So for the x minus 2, we have a power of 3, so it'd have multiplicity of 3. For the negative 1, which was x, came from x plus 1, it has a power of 5, so it'd have a multiplicity of 5. And those would be our zeros and our multiplicity for that problem. And that's what we're referring to here. Identify zeros and multiplicities of zeros. Now if I had another problem. If I had x to the third minus 12x squared plus 41x minus 42. I don't get that right. Let's see. X to the third minus 5x squared plus 6x minus 7x squared plus 35x minus 42. I'm just really drawing a blank on this one. X to the third minus 5x squared plus 6x minus 7x squared plus 35x minus 42. Negative 12x squared. Let me try a different one. Make them smaller. X minus 3, x squared minus 2x plus 1 gives us x to the third minus 2x squared plus x minus 3x squared plus 6x minus 3. And if this doesn't work, I'll give it up. X to the third minus 5x squared plus 7x minus 3. I'm not going to be able to make one up. Okay, let me stick with something simpler then. Let's say we got x squared minus 9x plus 14. Sometimes on these, now we'll be able to solve these here shortly, but that's actually the next I guess 3.4. So if we're asked to find the zeros in multiplicity, you set your function equal to 0, and on some problems you'll have to factor. So this one would factor as x minus 2 times x minus 7 equal to 0. Now zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So set x minus 2 equal to 0 and x minus 7 equal to 0. And that gives us 2 and that gives us 7. And those would be our zeros. Now if I were to put powers on these are like the first power. So for our multiplicity, it's whatever the power is up here, which would be 1 and 1. And those would be your answers. On some problems you have to factor by grouping, and that's why I was trying to make up a problem I could use factoring by grouping on, but it obviously wasn't as simple as I thought to make one of those up. Okay. Now, next topic. I guess that's it for that section. Let's go down to long division, synthetic division. Okay, long division. Say I got x plus 3 and I got x squared minus 7x plus 4, I guess. To do long division, we take a look at the first term of each, decide what goes up on top. And you ask yourself, what times x gives you x squared? And that'd be x. Now, whatever we put up on top, we're going to multiply by what's out in front. So we're going to take x times x plus 3. X times x is x squared. X times 3 is 3x. So we're going to have x squared plus 3x. Now we're going to subtract that line, which means flip signs. So this positive x squared becomes a negative, and this positive 3x becomes a negative. So then x squared minus x squared cancels. Negative 7x minus 3x is negative 10x. And then I'll bring down the plus 4. Now again, we look at the first term of each side, what goes up on top. So you ask yourself, what times x gives you negative 10x? And that'd be negative 10. Now whatever we put up on top, we multiply both sides in front. So we're going to take negative 10 times x plus 3. Negative 10 times x is negative 10x. Negative 10 times 3 is negative 30. And then we're going to subtract that line, which means flip signs. So this negative here becomes a positive, and this negative becomes a positive. Negative 10x plus 10x cancels. 4 plus 30 gives us 34. Now the degree. Degree is the largest power of x. If I look at x plus 3, the degree of that is 1. Now the degree of 34 is 0. Whenever the degree of this becomes less than what you're dividing by, this is always a remainder. And we take our remainder and we put it over what we're dividing by. So we'll have x minus 10 plus 34 over x plus 3. There are different ways you can write your answer on that, but that's one method. Now synthetic division. Let's say I had x to the third minus 7x squared plus 8x minus 2. And I want to divide that by x minus 2. This shows synthetic division. And there's 2 steps there. Our first step is we take what we're dividing by, which is x minus 2, and you set it equal to 0, and you want to solve. So that gives us x equals 2. Our second step is we're going to take the number we just found, we want to put in a box in the upper left-hand corner. So whatever you have right here, you can put in this box. Now we want to identify our largest power of x. Our largest power of x is x to the third. So real small, I'm going to write x to the third, x squared, x, and no x. Now we're going to write down the number that's in front of each one of those. The number that's in front of the x to the third is the invisible 1. The number in front of the x squared is negative 7. Number in front of our x is 8. And our no x, our constant term, is negative 2. Now we're going to go through a series of adding, multiplying over and over until we're done. So I'm going to add, multiply, add, multiply, add, multiply, and add. We start with our first column here. We're going to add. 1 plus nothing is 1. Then we're going to multiply. You always multiply by a number up in a box by a number you just put down here. So 2 times 1 is 2. Then we want to add. Negative 7 plus 2 is negative 5. Then you want to multiply. We always multiply by a number up in the box by a number we just put down here. So 2 times negative 5 is negative 10. Then we want to add. 8 minus 10 is negative 2. Then we want to multiply. You always multiply by a number up in a box by a number we just put down here. So we got 2 times negative 2 gives us negative 4. And then we want to add. Negative 2, negative 4 is negative 6. Now when you have no more columns to do, that's what tells you you're done. You can't go any further there. And we're ready to write down our answer. Now this right here is x to the third. Straight down below will be 1 degree lower. So that'll be x squared. This is x squared, so this will be x to the first, or x. This is x. This will be 1 degree lower, which is our no x, or our constant term. And then this last will be our remainder. Now after you have your first one, you have one for each one going down. So x squared, x, no x, remainder. So our answer is going to be x squared minus 5x minus 2, and then we take our remainder and we put over what we're dividing by, which is x minus 2. And that would be our answer. Let me grab a drink here. Okay, let me clear this off. And then we'll look at the next topic. Remainder theorem. If I have a function, specifically a polynomial function, let's say we got x to the third minus 2x squared plus x minus 7. And we're wanting to find f of 1. The remainder theorem states that if we're dealing with a polynomial function and we're evaluating, then we can use synthetic division, and once we do synthetic division, then our remainder is our answer. So we're going to take the number in the parentheses here, and that's going to be our number in the box in the upper left-hand corner. Now going back to our function, our largest power of x is third, so we're going to have x to the third, we'll have an x squared, we'll have x, and we'll have no x. I'm going to write down a number that's in front of each one of them. Number in front of the x third is divisible 1. Number in front of the x squared is negative 2. Number in front of our x is a 1. And our no x, our constant term, is negative 7. Now if I go through and add, multiply over and over, add. 1 plus nothing's 1. Then we always multiply by the number in the box, by the number we just put down here. 1 times 1 is 1. Then we add. Negative 2 plus 1 is negative 1. And then we multiply. You always multiply by the number in the box, by the number you put down here. 1 times negative 1 is negative 1. Then I add. 1 minus 1 is 0. Then I multiply. You always multiply by the number in the box, by the number you put down here. 1 times 0 is 0. And then add. Negative 7 plus 0 is negative 7. Okay. Now our remainder, this was x to the third, so straight down below it will be x squared. If that's x squared, then this is x, this is no x, or a constant term, and this is remainder. So f of 1 is going to equal to negative 7, whatever our remainder is equal to. That's what the remainder theorem says. Now I'm going to skip over the factor theorem in section 3.3, and let's get down to section 3.4. And we'll talk about the factor theorem once we work some problems down here. So let me clear this off. And I'm going to give you the whole process here. I'll first do one by hand. Let me make up one. Okay, so we got f of x is equal to x to the third minus x squared minus 7x plus 7. And this section is about finding zeros. And we already said earlier that if you're going to find zeros, you need to set your function equal to 0. So I got x to the third minus x squared minus 7x plus 7 equal to 0. I could factor this by grouping, but let's pretend we can't, because we're trying to learn this process. Well, if I'm doing this by hand, now I'll show it both ways. I'll do it first by hand, and then I'll do it by the calculator. If I'm doing it by hand, I need to identify my possible answers. Now, then we have a number at the very beginning. We have a number at the very end. The number at the very end will be our P, and number at the very beginning will be our Q. So the coefficient of the leading term, the leading coefficient, is Q, and then our constant term is P. Now we're going to write down all the products to give us 7. Well, this one's a pretty simple one. The only thing that gives you 7 is 1 times 7. But even more than that, we could take negative 1 times negative 7 gives us positive 7. So we account for that by putting plus or minus in front of each one of these numbers. Now our Q is invisible 1. The only thing that gives us 1 is 1 times 1. So I just simply put a 1. You don't repeat the numbers here. Rational zero theorem. What that's referring to is what are all of your possible rational answers. And how you get that is by doing P over Q. You take each value of P and you put it over your Q. You only have to put plus or minus 1 time though. So we'll have 1 over 1. And we'll have 7 over 1. Which then gives us plus or minus 1 and plus or minus 7. Now at this point, I'm going to take each one of those and I'm going to plug them into synthetic division into my original function and then see what happens. Okay, so our largest power is x to the third, so we'll have an x to the third, we'll have an x squared, x, and no x. Number that's in front of our x to the third is a 1, in front of the x squared is a negative 1, in front of the x is negative 7, and no x is a 7. Then we'll add, multiply, add, multiply, add, multiply, add, and we end up with a 12. Now what we're looking for is we're looking for a remainder of 1, or 1, remainder of 0. We have a remainder of 12, and that tells us that this is not an answer. So let's go to our next one. That was negative 1. Let's look at positive 1. So you just start going through your list, trying all of your different answers. Or all your possible answers, I should say. Okay, if I plug in 1, well, add, multiply, 1 times 1 is 1, add, that gives us 0, multiply, 1 times 0 is 0, add, negative 7 plus 0 is negative 7, and multiply, 1 times negative 7 is negative 7, and add 7 minus 7 is 0. Notice we came up with 0 as an answer. Now the factor theorem. We talked about, we skipped over. And you could read the book to see exactly what it says. But I'm going to give you the gist of how we use it in college algebra. Factor theorem says, if, and you're in this process, if your remainder is 0, then you found an answer. Now, another name for answer is 0. Because that's what we're finding, is we're finding zeros. Okay, so since we have a remainder of 0 here, that means this number in this box is our first answer. So x equals 1 is our first answer, so I'll go ahead and circle it. Now remember, this was x to the third, this was x squared, this is x, and this is no x. Now, I can write this down using this fact. This is x to the third, this will be 1 degree lower. So this will be x squared, this is x squared, this is x. And remember, when you have the first one, you have everyone going down. X squared, x, no x. And by default, this is a remainder. So that's going to leave us x squared minus 7 equal to 0. You put whatever numbers here in front of the x squared. 1 x squared is x squared. 0x. Anytime you have a 0, it drops away. And then negative 7 equals 0. Now this one, I can take the negative 7 over. It becomes a positive 7. And we can use the square root property. Square root property says if you got something squared equal to something else, you drop your squared and you put a plus or minus square root on the other side. Now, the fundamental theorem of algebra says your largest power tells you how many answers you're going to have. Since we had an x to the third, that means that we're going to have 3 answers. And we found one through the synthetic division, and then we did the square root property to get our other two answers. Now, instead of doing the square root property, you might have to factor at this point, or you might have to use a quadratic formula. Okay, let's look at this problem again. We've got f of x is equal to x to the third minus x squared minus 7x plus 7. This process can get tedious if you got a lot of possible answers. You might have to do synthetic division perhaps 10 times before you finally find your answer. Well, we're going to take a look at how to do it with technology. Now we're still finding zeros, so I set this equal to 0. So I got x to the third minus x squared minus 7x plus 7 equal to 0. So finding zeros on the TI-83, TI-84. Step 1. Put the polynomial on y1, 0 on y2. Step 2, we're going to do second trace. You're going to choose intersect. Then you'll do inner on first curve. You'll do inner on second curve. Then you'll input an answer. Input a guess close to your answer. And press enter. And then if you have decimals, you're going to do a second mode to exit out, and then you'll do math, enter, enter. I'm going to grab a drink here. Now we do not want decimals anywhere in this process, so if you have decimals, you ignore that particular answer. Okay, so let's take a look at this one. We'll go to our y equals, clear. We're going to put our polynomial on y1. So we got x to the third minus x squared minus 7x plus 7. And we want 0 on y2. So I'll put a 0 down here on y2. Process does not work if you do not have 0 on y2. Then we're at step 2. We're going to do second trace. And you can see from the buttons I push, it does them in red so you can see. So do second trace. We want to choose intersect. Now to choose the intersect, you can down arrow that line, press enter on it, or you can simply press the 5 that's in front of it. Okay. Now we're going to do enter on first curve. You notice in the bottom left-hand corner it says first curve question mark. So we just simply do an enter. And then we're going to do enter on second curve. And so I just simply do an enter on second curve. And then I say input a guess close to your answer and press enter. This over here looks like -2, -3. So let's put in -3. And then push enter. Now it gives us -2.645751, and I say if you have decimals, you do second mode, math, enter, enter. Second mode exits out, and then you do math, enter, enter. Now this does not change to a fraction, which means we can't use it. You can't have decimal answers on these. Well, let's go through the process again. So we're still in step 2. We'll do second trace. Choose intersect. Enter on first curve, enter on second curve. Our answers are where it crosses the x-axis. It looks like the first one, or the next one, is x equals 1. So I'll put 1 in for the guess and press enter. And it comes back and tells us the intersection is x equals 1. We'll come back to that. And it looks like I have another answer, like a 3. So I'll do second trace, choose intersect, enter on first curve, enter on second curve, and we'll put 3 in for the guess. Comes back, tells us 2.6457513. We got a decimal, so we're going to exit out. We'll do second mode, and then we'll do math, enter. Now that doesn't change to a fraction. They actually come in pairs. If you have one decimal will not change to a fraction, you'll have a second one. So all we found via the calculator was x equals 1. That's okay. We'll work with what we got. So we're going to take that 1 that we just found, and we're going to plug it into synthetic division. Remember, this is x to the third, this is x squared, x and no x. So add, multiply, add, multiply, add, multiply, add. Notice we get a 0. The factor theorem tells us that means we found an answer, which is no surprise. Calculator tells us an answer, so we better get a 0 there. Now this was x to the third. This is going to be 1 degree lower, so this will be x squared, this will be x, and this will be no x. So we're left with x squared minus 7, and we set it equal to 0. Why do we set it equal to 0? We're constantly finding zeros, so whenever you're finding zeros, you're setting it equal to 0. Now, the square root property, we're going to take the negative 7 over. It gives us positive 7. And the square root property says if you have something squared equal to something else, you drop your squared, and you put a plus or minus square root around the other side. And that gives us our other two answers. Now this just kind of gives you an idea of the process. But I'm going to have YouTube videos out there with a lot of examples. I think I got 6 or 7 examples I show using the calculator. I don't think I have very many by hand. But if you do need to see more by hand, if you're not using technology, let me know, and I can create a YouTube video very quickly demonstrating it. Okay, I'm not going to go over Descartes' rule of signs or upper and lower bounds. You can read those and find out what in the world they're talking about there. Let's talk about rational functions. And we got our vertical, horizontal, and slant asymptotes, and we want to graph them. Okay, vertical asymptote. Now, an asymptote is an invisible line your graph will skim at some point. Now, to find vertical asymptotes, what you do is you, step 1, factor the top, numerator, factor the bottom, the denominator. Step 2, cancel if possible. Step 3, set the denominator equal to 0 and solve. Okay, so let me erase this. Now, rational function, let me show you an example. Got f of x is equal to x minus 5 over x plus 7. Rational function. Of course, a function means it's a function, but a rational means you got a single fraction with variables in the denominator. Technically, you don't have to have variables in the denominator. Just rational means single fraction. For example, f of x equals 1/2 is a rational function. But this is typically what we see in college algebra. Now for our vertical asymptotes. Step 1, factor the top, factor the bottom. Well, there's nothing to factor. Step 2, cancel if possible. Well, there's nothing to cancel. Step 3, set denominator equal to 0 and solve. So we got x plus 7 equal to 0 and solve it, and I get x is equal to -7. Now that's our answer. In case you're wondering, what does that represent? I don't know much about this graph, but I know over here at x equals -7, my graph's going to skim it at some point. It's going to get really close to that line, but never touch it, never cross it. Now the trick to graphing these is you put parentheses around the top, parentheses around the bottom. So if I were to plug that in the calculator, I'm going to do my y equals clear, parentheses around top, so I got beginning parentheses x minus 5, closing parentheses divided by beginning parentheses x plus 7, closing parentheses, and then graph. A little hard to see here, but over here at x equals -7, then there's an invisible line the graph will skim at some point. It's probably not skimming it here, but if I keep watching as it goes down, it'll eventually get closer and closer to that line, but never touch it, never cross it. Same up here. As this is going up, it'll eventually get closer and closer to that line and skim it, but never touch it, never cross it. That's an asymptote. Now let's take a look at a little bit more interesting problem. So we got f of x is equal to x squared minus 1 over x squared minus 4x plus 3. And the instructions are still to find the vertical asymptote. Well, step 1, back to the top, back to the bottom. This is for vertical asymptote. Top part factors as x minus 1 times x minus 3. Bottom part factors as x minus 1 times x plus 1. Top part is PSD, the bottom part is the difference of two squares. Step 2, cancel if possible. Notice how they both have an x minus 1 now, so those are going to cancel. And we got x minus 3 over x plus 1. Step 3, set your denominator equal to 0. So we got x plus 1 equal to 0, and solve. And we get x is equal to -1. And that'd be our vertical asymptote. Okay, now let's talk about a horizontal asymptote. Remember, a degree is the largest power of x. And I've been referring to the top of the fraction, the numerator, and the bottom of the fraction, the denominator, as top and bottom, so keep that in mind. Horizontal asymptote. We have 3 cases. Case 1. The degree at the top is larger. Then there is no horizontal asymptote. Case 2. The degree of the bottom is larger. Then your horizontal asymptote is y is equal to 0. Case 3. Degrees are the same. And I like to do this with an example. Whenever I try to put this into words, it makes a really straightforward concept relatively difficult. Okay, we got f of x is equal to 4x to the third minus 7x plus 1 over 8 minus 5x to the third. Horizontal asymptote will be y equals 4 over -5. Okay. Degrees are the same. Degree is the largest power of x. Degree of the top is 3. Degree of the bottom is 3. So you create a fraction, taking the coefficient, the number that's in front of the x to the largest power. So I'll take the 4 there, put it on top, and down here I'll take the -5, the number in front of the x to the largest power. And that's where the -5 comes from. So a horizontal asymptote will be y is equal to -4/5. Now, let me look at the first 2 cases, because we're seeing an example of the third case now. Let me clear this off. And let's say I have f of x is equal to x to the third minus 7 over x minus 2. Degree is your largest power of x. Degree of the top is 3. Degree of the bottom is 1. Case 1. Degree of the top is larger. Tells us our horizontal asymptote. There is none. Now our second example. Let's say we got f of x is equal to x squared minus 7x over x to the third plus x minus 2. Degree of the top is 2. Degree of the bottom is 3. Degree of the bottom is larger. Case 2, degree of the bottom is larger. Your horizontal asymptote is always y is equal to 0. And that would be our answer. And that's the horizontal asymptote. Now the slant asymptote. In order to have a slant asymptote, the degree of the top must be exactly 1 larger than the bottom. And how you find the slant asymptote is you use long division and drop the remainder. So let's look at an example. We've got f of x is equal to x squared minus 8x plus 2 over x plus 1. And the instructions are to find a slant asymptote. Well, note the degree of the top must be exactly 1 larger than the bottom. Degree of the top is 2, degree of the bottom is 1. So it does have a slant asymptote for that reason. Then we're going to use long division, drop the remainder. So we got x plus 1, and here we got x squared minus 8x plus 2. So take a look at the first term of each, decide what goes up on top. You ask yourself what times x gives you x squared, and that'd be x. Now whatever we put up on top, we're going to multiply by what's up in front. So we got x times x plus 1. X times x is x squared. X times 1 is 1x or x. Now we're going to subtract that line, which means flip signs. So this becomes a negative. This becomes a negative. X squared minus x squared drops away. Negative drops away. Negative 8x and negative x gives us negative 9x. And then I'll bring down the plus 2. Now again, we'll look at the first term of each side, what goes up on top. So you ask yourself what times x gives you a negative 9x, and that's negative 9. Now whatever we put up on top, you multiply by what's out in front. So we're going to take negative 9 times x plus 1. Negative 9 times x is negative 9x. Negative 9 times 1 is negative 9. Now we're going to subtract that line, which means flip signs. So this becomes a plus, this becomes a plus. Negative 9x plus 9x cancels. 2 plus 9 is 11. But our instructions say to use long division and drop the remainder. So we're going to drop this remainder, and this is going to be our slant asymptote. That's going to be y is equal to x minus 9. Now the trick to these is just to plug them in your calculator by putting parentheses on top, parentheses on the bottom. Other than that, you pretty much just draw it as you see it. X minus 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Slant asymptote of y is equal to x minus 9 looks like this. This one, if I were to find it, has a vertical asymptote of negative 1. Which looks like this. It intersects the y-axis at 2. Look right there. So I know it skims this, And then it's going to skim this also. And I'm guessing it probably comes down below the x-axis. It may not. And then skims up like that. So skimming this on an angle that's at a slant. And then there's also another piece down here. But these asymptotes help you figure out what the graph is. Okay, that's section 3.5. Section 3.6. Let me grab a drink here. This is solving polynomial inequalities. Step 1. Get everything on the left side, 0 on the right side. Step 2. Set the left side equal to 0 and solve. And these don't give you something called the critical values, critical numbers. Step 3. Using the x-axis, the critical values, and the graph, then determine the answer. And if you got a greater than or greater than or equal to, then your answer is above the x-axis. If you got less than or less than or equal to, then your answer is below the x-axis. If you got a less than or greater than, you're going to use parentheses. If you got less than or equal to or greater than or equal to, you're going to use brackets. Okay, let's take a look at an example of this. Okay, so I got x squared, let me make up one, minus 8x plus 15 is less than or equal to 0. Step 1. Get everything on the left side, 0 on the right side. That's done. This process does not work if you don't have a 0 over here. Step 2. Set the left side equal to 0 and solve. So we're going to set the x squared minus 8x plus 15 equal to 0 and solve this. This factors as x minus 3 times x minus 5 using the PSD. Zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set x minus 3 equal to 0, and we'll set x minus 5 equal to 0. And that gives us 3 and 5. Now those are our critical values. Step 3, using the x-axis. So here's the x-axis. Here's 3 and here's 5. And these split them up into intervals. Clear over here is negative infinity, and clear over here is positive infinity, always. So using the x-axis, the critical values, and a graph. So you want to graph this, and you want to graph at the point where you got 0 by itself on the right side, which would work right here. So if I go put that in the calculator, y equals clear, I got x squared minus 8x plus 15, and then I'll push graph. Now what you'll notice is it'll cross at my critical values. Now if I sketch this graph that I'm seeing, if I sketch this, it'll look like that right there. You do not have to spend any kind of time making this look good. That's not the point of the sketch on this. Okay, now our problem's a less than or equal to. And we said a less than or equal to or answer is below the x-axis. So you look where your graph is below the x-axis. And it's below the x-axis in this middle interval. So this is going to be our answer. Now, that interval, by the way, is from 3 to 5, so I do 3, 5. Now, the less than or equal to says we use brackets, which means we put brackets on these numbers. And that's our answer. Now, if you had rational inequalities, let's say I had this right here. X plus 7 over x minus 2 is greater than 0. So rational inequalities. Step 1. Get everything on the left side and 0 on the right side. Step 2. Get a single fraction on the left side. Rational means single fractions. That's why you have to get that. Step 3. Back to the top, back to the bottom. Then set each factor equal to 0 and solve. These are called our critical values. Step 4, using the x-axis, the critical values, and the graph, then determine your answer. Note, any critical value that comes from the denominator always has a parenthesis on it, no matter what. Never a bracket. Okay, let's take a look at this example I wrote down. Step 1. Get everything on the left side, 0 on the right side. Everything's on the left side, 0's on the right side. That's done. Step 2. Get a single fraction on the left side. We have a single fraction on the left side. That's done. Step 3. Factor the top, factor the bottom. They're factored as much as they can be. And then set each factor equal to 0 and solve. So we got x plus 7 equal to 0. And we got x minus 2 equal to 0. Which gives us x equals negative 7 and x equal to positive 2. Step 4. Using the x-axis, here's negative 7, here's 2, and the critical values. Remember, these split them up into intervals. Clear over here is negative infinity, clear over here is positive infinity. And the graph. Well, we want to put parentheses around top, parentheses around the bottom. Remember, that's a trick to graphing a rational. If you have more than a single number, a single variable, you have to put parentheses around that part. So, I'm going to have, I'll go to y equals, clear, and I'll do a beginning parentheses, x plus 7, closing parentheses divided by beginning parentheses, x minus 2, closing parentheses, and then graph. Okay, well, it looks like going up to negative 7. Negative 7 is somewhere right here. I see a little bit above. If it's a little bit above, then it's above in that interval. And you don't have to sketch a graph. You're just identifying above and below. Between negative 7 and 2. Negative 7 is somewhere here, and 2 is somewhere here. Well, it is there. And I see my graph is below. If it's below in part of the interval, it's below in all of it. So it's below here. From 2 on. Here's 2, and from to the right, I see it's above. And if it's above in part of the interval, it's above in all of it. Okay, we got a greater than. And this says a greater than. Your answer is above the x-axis. Well, I see my graph is above here, and it's above here. So this is from negative infinity to negative 7, and this one is from 2 to positive infinity. Infinities always have parentheses on them. This is a greater than. Greater than tells us that we use parentheses, which means I put parentheses on these. If you got 2 or more intervals, you connect them with a union symbol. In some books, they have you put an or there, but that would be our answer. Now, last topic, I'm going to give you the steps, but I'm not going to show any examples. I have a YouTube video out there so you can see it. Variation is not something I can make up the problems out of my head, so I'll leave it to you to watch the YouTube videos on those. This is talking about variation. Okay, solving variation problems. Step 1. Determine the type. Now you'll have a direct variation where it's y is equal to kx. You'll have an inverse variation where you have y is equal to k divided by x. You have a joint variation where you have y is equal to kxz, although you can have more than 2 variables on the right side there. And we have a combo, which is a mix of the above. Now step 2, pick variables that make sense. X's and Y's don't make sense, but if I'm dealing with profit, for example, I'd use P. If I'm dealing with cost, I'd use C. Step 3, look for your one example, plug it into the formula in step 2, and solve for B. Solve for K. Step 4. Actually, let me go ahead and put it in here. And solve for K, then plug K into the formula from step 2. And then step 4, find what they really want. And like I say, after you look at the examples, those steps will make sense. Now, when I say direct, inverse, and joint, it won't be hard to determine those. These are word problems. They'll actually use those words. It'll say it varies directly or varies inversely. Now, those are the general forms that they take on. And I said this can have more than 2 variables here. If you have it varies jointly with 3 different variables, then you put kxza or whatever your variable is. Now, the k refers to your constant of proportionality. And your goal is to find out what k is equal to. And that's what you do in step 3. I think that's the last topic. Yeah, it's the last topic. So I'm going to save this video and get it uploaded. And I'm going to get online later on just to answer questions. I was going to be away from home, so I wasn't sure if I could actually record this and do all that. I knew I could answer questions, but I wasn't sure if I could do the other items.